Okay, let's take a look at 19 through 28. First off, make sure you pay attention that number 19 is talking about an even function, and numbers 19 through 23 are talking about even functions, and 24 through 28 are talking about odd functions. It might help then to have a picture of an even function and odd function in front of you, so you remember what they look like. Just your very basic even and odd function, your cubic and your x squared, your parabola. So in number 19, they want the integral for the area under the curve from -2 to 0. Well, when you have an even function and it's symmetric to the y-axis, they gave us the integral from 0 to 2 to 11/3. So since the function is symmetric to the y-axis, the answer for number 19 is also going to be 11/3. Now, when you think about number 24, when you have an odd function, well, if the area under the curve from 0 to 2 is positive 11/3, then the area under the curve from -2 to 0 is going to be negative 11/3, because an odd function is symmetric across the origin. I think you guys can figure out 20 and 25. I think you can also figure out 21 and 26, but I just will mention to remind you, when you have a negative f of x, the negative flips your function over the x-axis. So you'll need to be thinking about that when you do 21 and 26. 22 and 27 are similar also. They have this 3 on the outside of the function. Well, anytime you have a constant being multiplied by your function, you're allowed to factor that constant out to the front. So when you do that, you've got 3 times the integral from -2 to 0 of f of x dx. Well, we already figured out what that integral was in number 19. So for our answer here, we just have to do 3 times 11/3. And that's equal to 11. Number 27 is similar to number 22. Now, number 23 and number 28. I would maybe take some time and using the sine function, for example, that would probably help you understand 23 and 28 a little bit more. When you have a change on the inside, we're multiplying the inputs by 3. So using the sine function, for example, helps you think about this one the most. When we multiplied on the inside of the sine function, that changed the period. If this were the sine function, if we were graphing the sine of 3x as opposed to the sine of x, the sine of 3x would have 3 cycles in the same time that the graph of the sine function of the sine of x would have 1. Okay, not very good graphs, I know. You guys are probably getting a kick out of this handwriting. So maybe take a look at that on your calculator to refresh your memory about what happens when you multiply the input by a constant. So we can't factor that out here. We can't pull the 3 out into the front of the integral like we did on number 22. But what we can do is look at our limits of integration here. We go from 0 to 2, right? And they gave us this problem here, that 0 to 6 is equal to 15. So how would we use that to help us figure out number 23? Well, let's see. We've been doing u substitution, so maybe that will help us here. Let me scroll down a little bit. So we have the integral from 0 to 2 f of x, f of 3x, dx. So if we let u be equal to 3x, then du is going to be equal to 3 dx. Okay, now, look at what we have here in our original integral. We have a dx, but we don't have a 3. So let's go ahead and put a 3 in here so that we can make a substitution. We include a 3 here, we need to include a 1/3 out in the front. So let's see if we can rewrite this integral at all. We have 1/3 times the integral. We need to figure out our new limit. We plug in 0, we get 0. So our new lower limit will still be 0. And we plug in 2, we get 6. That was familiar. And then we have f of u 0. Well, they gave us that, didn't they? F of x or f of u. Remember that variable doesn't necessarily mean anything. So they told us f of x dx or f of u du is equal to 15. So we have here for our integral 1/3 times 15. Which is 5. So that's the answer to number 23.